Hello students, let's begin lesson 11b, hypothesis testing 1. Here comes another grand topic that requires more than 1 week. So we'll do the same thing as before. As we did for interval estimations 1 and 2, we're going to spend 1.5 weeks on it. In the latter half of week 11, as lesson 11b, we'll do sections 1 and 2, and the rest will be covered in lesson 12 in week 12. Okay, let's begin. Here's the introduction. The mathematical hypothesis testing consists of two competing hypotheses: the null hypothesis H0 and the alternative hypothesis HA. What do you mean by the null hypothesis? Well, what is null? Look up the dictionary. Null or null, both are correct by the way. Null means nothing, none, zero, empty. Basically, if you do nothing, you have to come back to the null hypothesis, which means this is the default, status quo, past consideration, traditionally what we had been doing. Now, the alternative hypothesis is literally the other one, alternative, different, new, those kind of things. Here's an analogy. In criminal justice system, for instance, H0 is not guilty and HA is guilty by law. What's the precise phrase? Presumed innocence until proven guilty, right? Is that it? Well, maybe I'm wrong. English is not my first language. Anyway, you see the picture. The burden of proof is on the alternative hypothesis. In order to make a case for HA, you have to prove beyond reasonable doubt. But how do we quantify beyond reasonable doubt here in math course? Kind of like this. Beyond the confidence level of 95% or 98% or 99%, kind of like that. We quantify like this. And anything smaller than 95%, I've never seen any of those. In classroom, I've seen 90% or even less, but outside classroom, nothing below 95%, to tell the truth. So that's what we're going to do. And here is a mathematical structure. The hypothesis testing problems look like this. So real mean is approximately the same as mu0 value, the null value. And please note that I'm using approximate equal sign because nothing is accurate in statistics, particularly here in hypothesis testing. We are doing this testing because basically we don't know. And then the alternative, no, significantly greater. Not just greater, but significantly greater. So I'm using the double inequality sign. But even if you use just equality and just single inequality, nobody will take off any point. But there's no question it's better if you do it this way. And same goes for the other way. Null is about the same as mu0 value. And the alternative is no. Real mean is significantly less than that. And then the third case, they're just different. Now I have some problem, the major problem about this last setting, because it's rare and impractical even. Obviously, our textbook authors disagree and put some emphasis on this one as well, which I don't really like. Theoretically, yes, we can consider this, but in practice, what's the point, you see? And you have sample study associated to this because this is a math course, and the sample mean is there, and the sample mean is much bigger than the null value, then of course you're going to do this. Much less than the null value, of course we're going to do that. Now, simply different, I don't know, why would anybody think of this? If they're too close, then of course no point for any hypothesis testing to begin with. Null would win. Now, if you have really no control over what the population mean will be, it may be much bigger, much less, I have no idea, because the data set is too spread out. In that case, you should not be doing this at all. You should be doing something similar to this or that, to standard deviations. You see, bigger standard deviation, then bigger spread, smaller standard deviation, small spread. You should be doing that instead of this, as if mu is totally out of control and that's a problem. In reality, sigma is too big, and that should be the problem. In short, I don't like this. So there's very little chance you're going to see this problem in my exam problem. Well, it may not be 0. I may write 1, or maybe I end up writing a problem like this inadvertently simply by copying a problem provided by the test generator. But again, I don't like this one very much. I'll focus much more upon either this one or that one, which are far more readily applicable to real-world situation. Now, one final comment here. There's something called level of significance, and that basically is a threshold. You see, I told you about beyond reasonable doubt. So confidence level of 99% or more. But what if you take the complement probability, that is probability that you end up doing wrong, so that should be 1% or less. More or less, that's what this level of significance is all about. I said more or less, not exactly the same. The precise answer will be discussed in 1.6, but that's got to be an optional section. Too hard. Okay, so much for the mathematical structure. Let us solidify our understanding through an example problem here. Please stop the playback and read through first. So what do we have? We have a type of paint, and then drying time, and we have to set up appropriate hypothesis. All right. So what do we have here? Null versus alternative. Null, that's approximately equal to, now we have some competing numbers. 75 minutes, okay, that's one candidate. 9 minutes, no, not really, that's standard deviation, clear. 72.3 minutes, oh, here's another candidate. And 25 observation, oh, that's sample size, no problem there. So basically, 75 or 72.3. Which is it? Which one do we want here? The answer is 75 minutes. Why? Because this is a null value, mu 0. 0 means null. Null means we did nothing. Now 75 minutes, that came out of nowhere. While 72.3 minutes, that came from something we just did. It came from the sample. So null means none. It should not come from the sample. So, one thing to remember, null means no, so null value must come out of nowhere, not from the sample. All right, next. And instead of 75, what did you get? We got 72.3 minutes, right? So is that the structure that we want? Is everything looking good? Now the answer is no. Compare with these. Does this fit any of these three? Greater or less or not equal? It doesn't fit any of those three. This is wrong. This is very, very common mistake here. The alternative hypothesis does not say mu is equal to some alternative value. No, it doesn't work like that. same null value has to be repeated. You see? mu0 here, mu0 there. mu0 here, there. Here, there. They should be repeated. The null value must be repeated in both lines. The 75.0 must be repeated. And then this should be greater or less. Well, 72.3 should be less than 75, right? So that should be the alternative hypothesis. For the direction, first read the problem and then cross-check with the sample mean. Read the problem first, carefully. The problem says, the proposed new additive is designed to decrease the drying time. The problem explicitly says so. So we want to go below what it was before. We want to go down. We want to decrease it. So this should be less. That's indicator number 1. Now sometimes you didn't read carefully. Somehow you missed it, or the problem is too complicated. In that case, there's a second criterion to hold on to. That is the sample mean. If sample mean is less, then it's got to be less, because if the sample mean turned out to be, say, 79 minutes, is there any motivation to do anything further? You have to have the same direction. For example, you're doing some research about COVID vaccine, and then you're supposed to have lower mortality rate after that, right? But then again, not vaccine, let's say medicine, mortality rate went higher. Then what do you mean by that? You got to stop that because clearly it's not working. So yes, sample mean should be in the same direction. That's the second indicator. First, read the problem carefully, and then cross-check with the sample mean. Remember all these 3 criteria, because I see a lot of mistakes in the initial setup. And once you screw up in the initial setup, after that, everything goes wrong. And hypothesis problems, those problems tend to be really long and have multiple parts, and can be something like 20-point problem for 100-point exam. So it's big. But if you make a stupid mistake in step 1 and miss all the rest, that can be devastating. That's why I really emphasize setting up the hypothesis correctly in the very beginning, from the very beginning, and remember these 1, 2, 3. All right, we went through this example. Now we have some time, so let me show you some picture associated to this. Okay, we have it here. And this picture shows how we actually test the hypotheses. What we want is based upon something called the significance level, which basically measures the probability that we do it wrong, this red area, and find out the threshold. Compare the sample mean with the threshold. Close to the null, then we take null hypothesis. Obviously, it's easy to see. If it's too far away from the null, then of course null is wrong. So it all boils down to finding out this threshold, the critical value, and that's something we're going to focus upon in the next section, in section 2. Remember this kind of graphics